Okay, what we're going to do next is take a look at the examples from section 4D. So starting with the first one, what do we have here? After graduating college, Brenda has $43,000 in student loans at a fixed APR of 3.4% with a term of 20 years. So that's the situation. First thing to do is to put names on what the numbers mean. So the $43,000 is the amount that she borrowed, and so that's the principal. That's what she needs to pay back. APR is obviously the APR, and the term is 20 years. So looking back to the loan payment formula, we know the principal, we know the APR, and we know the number of years. The question is, what are her monthly payments? And because it says monthly, we know N is 12. And so what we're going to do is plug this information, and then that will allow us to calculate the monthly payments. So we'll do this once the hard way, and then I'll show you the finance spreadsheet where we can do the calculations on there. So let's make this a little bit smaller so we can see the formula, but also see the information. Okay, so we want to calculate the payment. Let's look at the numerator first, the top. We're going to take the principal, 43,000, multiply by the APR over N. Now remember, we always put the APR in as a proportion, as a decimal, not as 3.4%, but as 0.034, and then divided by 12. So this is the numerator, P times interest rate over 12. Now what you can look at for this, or what you can think about this, is this is sort of the amount of interest owed based on this principal for a 1 month period. The interest rate for the full year is 3.4%, but each month we're really just paying a 12th of that. And then what do you need to pay is determined by all this other stuff that's in the denominator as well. So we need to take that interest payment amount and divide by everything in the bottom. And so that starts with a 1 minus, and now I'm just going to follow the parentheses here, 1 plus APR, 0.034, divide by 12, and then close parentheses. Now this quantity that's in parentheses is raised up into the power of negative, don't forget the negative sign, 12, because N is 12, times, oops, I came out of the parentheses, times, oh, I guess I need to put this in parentheses in order to do the multiplication, 12 times the number of years. And her term is 20 years, so I'm multiplying by 20. So I have everything in just as it appears here with the appropriate parentheses. I put this in brackets on the screen, I think, just so it looked a little bit more contained, but they're really unnecessary. I could put brackets around the expression here and it wouldn't change anything because it's all underneath the dividing line. But everything else is appropriately expressed. And we get an answer of 247, if I round to the proper sense, 18. 247.18, and that is the amount that you would have to pay monthly in order to pay off this loan of $43,000 at this interest rate in 20 years. Okay. Now the next question, how much does she pay in interest over the term of the loan? So this is one where I haven't given you a formula to do it, but I want you to think about what you need to do to figure it out. So use your critical thinking skills here. How much does she pay in interest over the term of the loan? Well, the principal is $43,000, so that if she didn't pay any interest at all, she would just be paying back $43,000. But now in part A, what we calculated were her monthly payments. She's paying $247.18 per month. She's doing that for 20 years. So what we can figure out is how much she's going to pay in total. So let's do that first. 247.18 per month. So each year, you multiply by 12. So each year she's paying a total of $2,966.16. And she's going to do that for 20 total years, which means her total payments amount to $59,323.20. Okay, so we know the principal, what she would have to pay if she paid no interest, and now we know what she pays with interest, and so how much she pays in interest is the difference between the two. So $59,323.20 minus $43,000. So what she pays with interest, what she would pay without interest, the difference, $16,323.20, is how much she pays in interest alone. So that's what the lender, the company that she borrowed the money from, gets paid in order to lend her the $43,000. And then the last part, C, what percentage of her total payments goes to the principal? So now we need to think about how much goes to the principal and how that compares to the principal. So of this $59,323.20, $43,000 is what the principal is. Okay. Her total payments were this many. So the percentage, so we have 43,000 out of 59,323.20. Make it a percentage. 72.5% of what she pays goes to the principal, which means on the flip side of that, 27.5% goes to interest. So about 3/4 of her payments go to the principal and 1/4 of her payments go to the interest in this particular circumstance. Okay. Let's move on to the next one. Now we have a couple, Bob and Beverly. They buy a house with a 30-year mortgage, so the term is 30 years. The loan amount is $280,000. It's a fixed APR of 3.75, and we're going to basically answer the same questions. What are their monthly payments? How much do they pay in interest? What percentage of their total payments go to the principal? So we can do this the same way. I could change the numbers here and then update what the totals are. So let's do it that way, and then that's the last time we'll use the formulas here, and then we can compare it to what we get on the finance spreadsheet. So instead of 43,000, it's 280,000. Instead of 3.4%, it's 3.75%. Still monthly payment, so that stays as 12. Don't forget to change the interest rate in both places. And instead of 20 years, it's 30-year mortgage. Okay, so for a 30-year mortgage of this amount of money, you're paying about $1,300 a month. So that's the answer to part A. Monthly payments are around $1,300 on a mortgage of that amount. How much do they pay in interest? Well, now we need to take that amount and put it in here. $1,296.72. 12 months each year, and now for 30 years. So they're going to pay for this $280,000 home, they're going to pay $467,000 almost. Okay, so how much of that goes to principal? We're going to figure out what percentage goes to principal, but how much of it goes to, we're on part B. How much do they pay in interest? So how much goes to interest is the difference between how much they pay in total and what they pay in the principal, which is $280,000. So in this case, there's about $187,000 that went towards interest alone. So what percentage of their payments go to the principal? Well, the principal amount was $280,000, and the total amount was $466,819.20. So in this case, 60% went to pay off the principal, which leaves 40% of the loan is actually interest charges. And these, I would say, are all pretty typical numbers. 30-year mortgages are, I would guess, the most common. I haven't actually looked at the numbers on that, but in my experience, just knowing about other people's mortgages, what limited knowledge I have of that, and my own thinking about it, 30 years are the most common. 280,000 would be a reasonable price for a decent family home in at least in this area, and 3.75% would be a reasonable interest rate. So these are reasonable numbers. Over the course of that loan, you might pay 40% of the cost in interest. So borrowing money can be expensive. Okay, before we move on to the next one, let's see what we can do with the spreadsheet. Let me make it a little bit smaller here. So this is our finance spreadsheet, and I'm on the 4D tab. So I've set up a calculator here where you put in the loan amount. So the Bob and Beverly borrowed $280,000, and their interest rate was 0.0375, and their payment was $1296.72. So when you enter the information here, it updates the table that's down here. It tells each month, starting from the initiation of the loan, what the balance will be, so how much you still owe, how much interest is accrued, how much payment goes to principal, or sorry, this is how much of the payment goes to interest, this is how much of the payment goes to principal, and then this calculates the percentage to interest. So in this case, that was 40% total. Now this number isn't to be compared to this number exactly, because this is for that one specific payment, not for all of the payments in total. Now what you'll notice is that over time, the amount you pay to interest goes down, and the amount you pay to principal goes up. That's because your balance is going down, so there's less interest being accrued. And so that's a good thing. So over time, your payment to interest goes down, your payment to principal goes up, and so the percentage that goes to interest goes down. And so this is a nice tool for seeing what happens to the loan over a period of time. And it's set up to go to 36 months if you wanted to, 36 years, no, 36 months. You can just drag the formulas down and extend the table however you want. Okay. But then we figured this number out manually. So loan amount was given, APR was given, and we figured this number out from the loan payment formula. Here, this calculator tool will do that for you. So if we put in 280, 0.0375, and the term in this case was 30 years, that's where that number comes from. Okay, so we can use this tool. Let's put this away for a second, and then we'll take a look at the third example. All right, now here we're dealing with credit card debt. So Benny was unemployed. He accumulated $8,000 in credit card debt. He hopes to pay off the balance in monthly payments over 1 year, and his card's APR is 17%. So he has a goal of paying it off in a year. So the term of this loan, he's thinking of it as 1 year. It's $8,000 in principal. We're going to answer basically the same questions. What are the monthly payments? How much does he pay in interest? And what percentage goes to principal? So again, we could do that here, but I've just shown you this nice tool that does it in a couple keystrokes. So Benny has $8,000 in credit card debt. His APR is 17%, so 0.17. And the term he's thinking of as 1 year, so we want to just put 1 here. Okay. So in order to pay $8,000 of debt at this rate, you'd need to pay $729.64 per month. So that's our monthly payments. So how much does he pay in interest over the term of the loan? Now, we're basically doing the same questions. We could use the table to figure this out as well, but I think it's helpful to think through on the calculator screen. So we're not using this formula right now, so I'm going to just delete that one because we're doing it with the spreadsheet from this point. How much does he pay in interest? So he's paying $729.64 per month. 12 months per year over the course of 1 year. That will pay a total of $8,755.68. Notice that that doesn't add to 8,000 because it's including the interest that's accrued at 17%. Okay, so what we do is we take the 8,755.68 and we subtract the principal, and now we know that there's $755.68 of interest charges. And then we can go from here to figure out what percentage goes to the principal. So 8,000 is the principal. $8,755.68 is the total payments, and so 91% in this case goes to the principal, and that's because it's paying it off such a fast or such a short term of just 1 year, and so there's only enough time for $755 of interest to accrue. Okay. So these are the answers to these questions. Monthly payments, $729.64, pays a total amount of interest of $8,755.68, and 91% goes to the principal. Okay, now we're going back to Bob and Beverly, and they notice that their bank offers a 15-year mortgage with a fixed APR of 3%. What if they go with this loan for their $280,000 mortgage? What will be the monthly payments? So now we're comparing the two. We're going to be comparing the two loans. So before we got an answer of $12,960, and what will we get here? So the same loan amount, different interest rate, 0.03 instead of 0.0375, and a different term, so it's 15 years instead of 30. So what will be the monthly payments? The monthly payments will now be $1,933.63. Okay, so the big question is, how much less will they pay going with the 15-year loan compared to the 30-year loan? They're obviously paying quite a bit more per month, $1,900 versus $1,300. So about $1,600 difference per month. I mean, $600 difference per month. Over the long term, how much does that pay off? So let's figure out what it is in both cases. I'm going to just delete these and start fresh. So in the 30-year mortgage, they're paying $12,970 per month, So 12 months for 30 years. In the 15-year mortgage, they're paying $1933.63, 12 months a year for 15 years. So here we have $466,812, $348,053. What's the difference? $466,812 minus $348,053.40. And the difference is almost $119,000. So she pays, or Bob and Beverly would pay almost $120,000 less by going with the 15 versus the 30-year loan. Now, let me just end this by saying that in the previous video, I talked about the differences and the complications in loans and how some small changes can make a huge difference in the long run. This is what I'm referring to in large part. If it's feasible to pay this higher amount, which is not always the case, sometimes you can't pay the monthly payments on a 15-year mortgage, but if you can, in the long run, it typically saves you on the order of $100,000 to go with paying more now over a shorter period of time rather than paying less over a longer period of time. So if the option came to do this and you could afford the higher payments, you're financially better off going with that in the long run. Okay, those are the examples. Please go through them on your own. Make sure you can get the numbers to work out as I did here, and let me know if you have any questions.